Okay, so we start with the hypothesis testing for the mean. Here we are using large sample. As we said earlier, large sample means when the sample size is equal to 30 or greater than 30. So in this section, we are going to learn how to find the p-values and use them to test a mean, and also use the p-value for z-test. I think that's one of the first hypothesis testing. Z-test is a parametric test. It's based on the z-value. Most of the time, we don't do z-test because doing z-test, we have to know the population standard deviation. So with the t-test, we can use the sample standard deviation. So again, let's go through. So next, we're going to find the critical values and the rejection region and normal distribution. Then we use the rejection region for the z-test. Okay. So next, decision rule based on the p-value. We mentioned that already. To use a p-value to make a conclusion hypothesis testing, we always compare the p-value with the alpha. Alpha is the level of significance. And as we said earlier, if the p-value is less than alpha, then we are going to, again, reject HO. But if p-value is big, at least equal or greater than alpha, then we are going to fail to reject HO. So if p-value is less than equal to alpha, then we reject HO. If p-value is greater than alpha, then we are going to fail to reject HO. So example is given here. The p-value for hypothesis testing is given to be 0.0237. What is your decision if the level of significance is 0.05? 0.05 is greater than 0.0237. So which means the p-value is less than the alpha value or the level of significance. So in this case, we are going to reject HO. So we say that's because 0.0237 is less than 0.05, you should reject the null hypothesis. Second question, what if it's 0.01? 0.01 is greater than 0.0237. So this are now, we say we will fail to reject HO. Why? Because our p-value is greater than the level of significance, which this time is 0.01. So 0.0237 is greater than 0.01. So we fail to reject HO. As we said, when the p-value is equal or greater than the alpha, we cannot reject HO. P-value should be small, at least smaller than alpha value. Then we are going to reject HO. Now, how do we find the p-value? Yes, we can use our table. Most statistics textbook come with a table. For example, t-distribution table, chi-square table, so many of them. And also standard normal curve table, which is the C table I'll use. So here we say after determining the hypothesis test in standardized test statistics, and also the test statistics corresponding area, then we can do one of the following to find the p-value. First, for a left tail test, we look at the area in the left tail. For right tail test, we look at the area in the right tail. For two tail, we have to the area in the area in tail of the test statistics times again the two. So here they say we should find the p-value for the left tail hypothesis testing with a test statistics of z equal to negative 2.23. Also, we should decide whether to reject HO if the level of significance is alpha equal to 0.01. So here they give us the z value, so we have to go and look the p. So that's the z value given already. Normally, if they give you x value, we have to look for the z value for that corresponding x value. In this case, surely we have to know the mean of the data set and also the standard deviation to be able to find the corresponding z value for the x value. Unless you are using a software, then everything is in the software. Okay, so we went to the the z-test, z-distribution table, the z-table, and we found out that the corresponding z-value negative 2.23 will give us 0.0129. Since 0.0129 is greater than 0.01, we say here you should fail to reject HO. Wait for a few seconds if it's okay. Again, how do we get the p-value? Because we know the z, so we can go to the table. I think we did that in chapter 4 or 5 when we were doing the distributions, normal distribution. We covered the concept here. Find the p-value for the two-tail hypothesis testing. Now here it's a two-tail, so we should be careful. The z-value also is given. So if z-value is given, then we can go straight to the table, and then we can, this is 2.15, we can find the z based on. So based on the z-value here, we have 0.9838. Now, anytime we are looking for the p-value from the table, the answer given always is from the result to the left. You don't go to the right. Again, I think we covered this already. So this means from here all the way to the end. But I want to find up to here. From here to here, maybe it's different, and etc. So, or if I want to find, for example, if I know from here to here, 1 minus everything here will give me this small section. So we'll wait for a few seconds if the diagram is okay. It's two-tail. Previously, if it's now if it's greater, I will still find it, whatever the value is, all the way to the left. Lesser, or the table always will read the position to the left. You don't go to the right. So if you're looking for some right value, then you have to do some subtraction of the area of the curve, get it. So that's what they did here. 1 minus 0.9838 will give us this section. If that's the case, we multiply it by what? 2. And that gives us 0.0324. Now, let's compare with our alpha is 0.05. Now, since 0.0324 is less than 0.05, we are going to reject HO. Okay. So that will lead us to the z-test for the main mu. And here we say the z-test for a main mu can be used when population is normal. And also because the z-test is a parametric testing. So we always have to test for the normality of the distribution. We normally can use Shapiro, and also there's another one, start with K, Komoronov or something, Komonorov. And basically we can use those two to test this normality for the distribution. Here also, our data here, again, we have to be careful whether it's a small sample or large sample. A large sample means it's equal or greater than 30. When the sample size n is at least 30. So here we say can be used when the population is normal and the standard deviation is known, or for any population when the sample size n is at least 30. So that's for large. So next we can find the test statistics, which is the sample mean X bar. So the standard test statistics is Z, which will be S bar minus mu over standard deviation of the population divided by square root of the sample size. Normally, we will say that the standard deviation divided by square root of the sample size is called a standard error. Okay. Now, when n is greater than or equal to 30, then the sample standard deviation S can be substituted for the population. So we are using the sample standard deviation instead of the population standard deviation. Only if the sample size is large, which means greater than or equal to 30. So that's the steps here. In WAS, the first thing we do, this is for z-test for the population mean. First, we state the claim mathematically and verbally, identify the null and also alternative hypothesis, which is HO and HA. Then we specify the level of significance, identify the alpha. Then we can determine the standardized test statistics using the z equal to x bar minus mu over standard error or standard deviation divided by square root of n. Then we find the error that corresponds to the z using again, this textbook, the table is table 4 in appendix B. That is the standard table, the z table. So from the z table, we can find the corresponding p-value also. So we find the p-value for the left tail, p equal to the area in left tail. For the right tail, the same thing, but for two tail, we multiply by 2 and area in the tail of the test statistics. Then we make a decision whether to reject or fail to reject null hypothesis. And that depends on the p-value, whether it's greater, less than, or equal to alpha, the level of significance. Then we interpret the results. So let's see, I think our time is gone. We have 2 minutes. Let's see if we can do this example. Here they say in advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. So this will be HA, only less. A random selection of 36, okay, that's good. The sample size is more than 30. So we can substitute the standard deviation of the sample. We can use that sample standard deviation instead of population. Then a sample mean of 28.5 minutes and a standard deviation, so it's good. Is there enough evidence to support the claim? So our alpha is 0.01. Okay, so everything is given. We can follow all the 4 steps. First, we state the HO based on the question less than 30. So HO will be greater than or equal to 30. Alpha is already given 0.01. So we can go ahead and find the test statistics. Remember the mu also is given, which is right here. The standard deviation sample is also given the question, 28.5. Standard deviation is given also. So our Z is negative 2.57. Okay, go to the book and then we can find the p-value. But first, again, we draw this concept here and we have our Z value. We look at the table and we get 0.0051. So now it's 0.0051. It's way less than 0.01. So we are going to reject the HO. So again, first we state the HO and HA. We check what the alpha always will be given to us. So sometimes if it doesn't give it, they didn't give to us, we can use 0.05 as a default, especially if you are using the software. This is a z-test, so we find a z and then we do it. So here we say 1%, alpha is 0.01. So at 1% level of significance, we reject HO. So this means we have sufficient evidence to conclude that the mean delivery time is less than 30 minutes. HA is true. Then we have another example here, but again, we're going to skip this example, the same concept because of time. And the same thing based on the question, HO is given, HA is given, alpha is given, test statistics, we find it. Samples, mean and standard deviations are given. The sample size also is 30, so that's good. So we find, and since 0.1310 is greater than 0.05, we are going to fail to reject HO. So at 5% level of significance, there's not efficient evidence to conclude the mean franchise investment is different from 143,260. We fail to reject HO, so it's equal. So that will be the conclusion for these lectures. Again, because of time, we are kind of a minute. It's already time. And we already saw this concept, a few examples already. So we are going to skip the rest. This is for two-tailed tests. So wait for a few seconds if we have any question before we go. Okay, so if no questions, we said earlier, next week is our final week and we're going to take the final exam. The final exams are 50 multiple choice questions. We may see, and all of them are theory, but again, we may see some R questions like what we cover in earlier weeks, same as the midterm exam. Some couple of questions, but there will be no coding. We are not going to write no code, but we should understand that. For example, we should know what is R Markdown. We can have a question on R Markdown, but it will be theory. You don't have to write a code. What they are, what are their benefits, their function, etc. Yeah. Same thing with SQL and R. We should understand the theory, no coding. Okay, so if no question again, thank you for your time and we'll see you next week.